All right, everybody. Today we're going to be learning about radicals and rational exponents. So there's a connection between radicals and rational exponents. So here we go. Now, the first concept is going to be evaluating the nth root expression. So before we can get to that, let's do a little bit of a recall, something that we've done before. Now, when we've been talking about powers, now remember, we have to know the meaning of powers. And so when we see something like 2 to the power of 3. Now remember, that's our power. The 2 is what we call the base. That's what we've been saying lately. But when we see a power of 3, the meaning is we're supposed to write the 2 3 times. And we're supposed to multiply it to itself 3 times. Well, that's why we have calculators, or we could just do it on our own. 2 times 2 is 4. 4 times another 2 is 8. But again, you have calculators that can help you figure this out. So the meaning of powers is whatever the power is, that's how many times I should see the base written out. And of course with multiplication. Now, the newer concept is this idea of a root or radical. So it says the symbol for a cube root is a third power, right? Well, it has to do with powers of 3. But it has an index, is what we call it, an index of 3. So this right here, that little 3, is what we call the index. So let's write that in there. So if this is the index, and the question becomes, well, if 2 times 2 times 2 is equal to 8, when we see a radical, or in this case, a third root, we call it, or a cube root, has a couple different names, what they're asking is this: what number do I multiply to itself 3 times, because it's a cube root, to get an answer of 8? Well, we just saw it over here, and that's why we can do this problem right away. We know that the number that you would multiply 3 times to itself, because it does have to be the same one, would be 2 times 2 times 2, because that's what gives me that 8. So when we do a cube root, they're asking, all right, what's that magic number that we multiply over and over and over? It's the number 2. Again, they don't want me to write it 3 times, right? This is what I'm thinking of. The answer itself would just be the 2 on its own. So one of the things that we have to understand is that on this side, when you're working with powers, and then over here, we're dealing with radicals. And by radical, we mean this symbol only. This symbol by itself is what we call a radical. That's why when you put a little 3, this is a third root or a cube root. It has a special name for it. But what we have to understand is that powers and radicals are basically the opposites of each other. So they're opposites. See, a power says, well, write it 3 times and then multiply it. Well, a radical is asking, okay, well, what did you multiply 3 times to get that 8? So it's kind of a there's a similarity or connection between them. Now, when it comes to a radical, so we already said what a radical is. We'll write the symbol down again. But whenever they say the word radical, we're talking about this symbol right here. Just this symbol with nothing else. Okay? So when we talk about radicals, well, we have different ones. A lot of the times people will see this and say, oh, that's a square root. Well, technically, it can be, but it's usually a radical. And the reason people think it's called the square root is because of this. When you see this symbol and you don't see a number here, now I know we're used to always saying, oh, it's an invisible 1. Well, in this case, there's an invisible 2. It's so common that we don't even write it down. But when we have an invisible 2, yes, we call this a square root, because of the 2, so it's a square, right? A power of 2 is called a square. If we have, just like this example over here on the side, if we have a 3 as our index, remember this is what we call the index there. If we have a 3, we can call it a cube root. Or as some people just say, this is the third root. You could call it that as well. That's why if you see a 4, you could say it's a 4th root, a 5th root, depending on the number. But these are the special names and the ones we see the most in math. But then, of course, it could also just be this. What if we call it an nth root? Meaning it could be any number we want there. Well, that's why we just said we would call this an nth root. So it just depends what number they have there. The idea, though, is powers and radicals are opposites of each other. So one of the big things that we're going to be learning in math, especially in high school, is the fact that we use radicals to cancel powers. And we may not be doing that yet, but we want to start throwing that idea out there. Powers and radicals are opposites of each other. So if I ever want to cancel a power, well, I'm going to bring in a radical. And if you think about it, what's going to cancel a radical? Well, powers. They're opposites of each other. There also is a connection between an nth root, a radical, right, and a power. And so here's the last idea, and the one that we're going to be using today the most. So here is the last special note we're going to write here on top. So it says, if you have the nth root, now I'm just going to write any letters here, so I'm just going to write an A. What they want to let you know is that whenever you see a radical, it actually represents a power. And so my base is A, so I'm going to continue to write that A. But anytime I see a radical, it means that my power used to be a fraction. So my power used to be a fraction, and the one thing that we should note is that this little number right here, or this value, that n, is always going to be at the bottom of a fraction. So there's my n, and then the a has a power of 1 that's invisible, so we just put a 1 here for now. But this is one of the skills, and we're going to practice it more. We're going to see it on the next page more than here. But that's one of the bigger notes for today, is the fact that radicals and powers are related to each other. The only thing is, when you have a radical, it's the only time you're dividing, and that's what a fraction represents, a division of powers. So we're going to show you shortly. You got to make sure you do have a calculator handy and ready to go. Remember, we do have a button that allows me to do powers. That is the caret button here. So we're talking about this one. Let me do this so we can see it. That's the button that we use for powers, but we're also going to use it for radicals. If you look right on top, let me see if it works if I zoom in. See, if you look right on top of this here, if we look right on top of this button, there's a radical with a little x on the outside. This is the radical button that we're going to be using the most. So just have it ready and handy. Okay, so let's go back to the note. So we're going to look at example number 1. It says evaluate each expression. And so it says 3, the cube root, or the third root of -8. All right, now remember, I only need one number here. I don't need anything else. I only need one number. But because it's a power of 3, a cube root, the question is, what number do I multiply 3 times, and it's got to be the same number, so that I get -8 as a result? Well, we kind of saw it earlier, right? A little cheating here, but look, 2 times 2 times 2 is equal to 8. Okay. Now, when we're looking at this one with the cube root of -8, we already said the -8 is 2 times 2 times 2 is a positive 8. So then if I want to get a negative out of it, well, then I'm going to try -2 times -2 times -2. So we're going to test it out. -2 times -2 times -2. We're going to play it safe. We're going to make sure it works. -2 times -2 times -2. Yeah, there it is. So -8. So it does work out. But remember, the only number I'm actually going to write in here is -2. And there's my answer. Okay? So again, we're looking at what's the number that I can multiply to itself 3 times to get that result. Now, when you look at letter B, you might say, hey, they're pretty much the same question. Not quite. If you notice, the negative was on the inside, but here, the negative is on the outside. And so the question becomes, well, how do I handle a negative on the outside? It's actually one of the easiest things to do. If you have a negative on the outside, not the inside, but when you have a negative on the outside, it just means write the negative on the outside, and that's it. All I'm going to worry about is what's left. So if you have a negative outside, just write your negative already. So again, look, they're asking me, what number do I multiply 3 times to itself to get an 8? Well, again, it's the same number we've been working with, but notice, now it's a positive 8, not that negative. That negative was done. This is a positive 8. What's the same one we saw earlier? We know that 2 times 2 times 2 is going to give me an 8, which means, remember, I don't write all 3 numbers. The only number that I'm writing in, remember, I already had that negative from earlier, is the 2. All right. Now, moving right along. This one I know doesn't look like this at all. I know they don't look like each other. But remember what that little note was, that special note up here. We said a radical and a power that's a fraction are connected to each other. So if they are connected to each other, then I'm going to rewrite this. I'm going to write this out as, here's a radical. So again, when you see a fraction, it means write a radical. Now, the 16 that we see as our base is what goes inside. And now let's look at our index. Our index is the 4 would go right here. So the denominator is what we write out here. Now, there's just a 1 on top, so we don't have to worry about writing a 1. But now that's the problem that we're going to answer. So we finally get something different here. So for this problem, it says, I want the 4th root of 16. Okay, well, what they're asking is, what number, it's got to be the same one, do I multiply 4 times to get a 16? Now, you could try things out, of course. So here's my calculator. But remember, it can't be different numbers. They're all the same. And I'm trying to get a positive 16 out of it. All right, well, if you're thinking, oh, 4 times 4. Okay, but remember, you said 4 times. 4 times 4 times 4 times 4. So that's not a 16. That means the number's got to be a lot smaller. Well, let's try the 2. I know we've been trying the 2 lately, so let's try the 2 here. All right, so we're going to try the 2, and it says, all right, 2 times 2 times 2 times 2, and there it is. There's our 16. So we know that the number we're going to use, and again, I'm not going to write 4 of these numbers. I'm only writing one of them down. The 2 is the one that gets repeated over and over and over and over. That's what's being asked here. All right. And then, of course, we have this last one here. And again, look, it does have a power that's a fraction. So what we said was, when you have a power that's a fraction, that means you got to start writing a radical for it. And, of course, there's a negative 16 on the inside. So negative 16 on the inside. And what we said was, when you see that power that's a fraction, you write the radical, but we have an index of 4. So we put our 4 right here. The denominator is your index. And so now the question, you might say, oh, it's the same one as this one, mister. Well, careful, there's a negative inside. So I'm going to test it out. A number times a number times a number times a number, but I want to get negative 16. Okay, and if I'm trying to get negative 16, let me zoom in for you here. All right, now we tried 2, 2, 2, 2. That was a positive 16. So I guess we could try negative 2. Let's see what happens if we multiply negative 2 4 times. So negative 2 times negative 2 times negative 2 times negative 2. Again, 4 times, and it has to be the same number. All right, let's see what happens. Look at that. It's a positive 16. I'm trying to get a negative 16 out of it, so this didn't work. And we already know 2 times 2 times 2 times 2 is positive 16 also. Well, then there is no number that works for this. And when no number works, right, because this right here equaled positive 16, well, nothing is going to work, so we just say not possible. We just can't do it. There is no number that is going to work for this one. So again, one of the things that we're going to learn is that we cannot take the even root, because the number 4 is an even number, the even root of negative numbers. So we are not allowed to do that. All right. Now, this is how we do it the old-fashioned way. With us trying to think of numbers that work, but you might say, yeah, Mr. Then I have to try a bunch of things. And yeah, we got lucky that all of these were 2s. Well, yeah, we did that on purpose. But here's why we need you to have your calculator, okay? So have your calculator handy. We're about to show you how to do these problems very quickly on your calculator, which means you can also do your classwork and your homework using the calculator so you can finish it even faster. So the first thing I want to do is get a cube root. So I'm not going to use just the power button here. If I want to use a cube root, let's see, we can see it better there. All right, so here's how you do cube roots. Remember what I said. I need to use that green X root right here. And if I want to use stuff in green, well, then I have to press the green button. So I'll press the green button. And then that. But then notice, it says answer, something like that. What you have to let the calculator know is you want a cube root. So you're going to press the 3. Now I'm going to press the green with the caret button. Look at that. There's my cube root. And I'm going to do a cube root of -8. So make sure you type in the negative, not the minus sign. -8. And then look, press enter. There's my answer. See? Instead of doing all this work, man, the calculator could do it all for us. And that's what we want to practice here. Okay? So here we go again. Let's try it again. Now this one, I got to type it in the way I see it. So I have to hit the negative button first. So here's the negative button. Now I'm going to do a cube root. So I'm going to press 3 and then do second radical and then the 8. See, and there it goes. -2 once again. So again, to get to those cube roots, you have to press the second and the caret button. The one that gives you powers, the power button. All right, let's try it again. Now here, we're going to be using this one right here. So I'm going to clear this. All right, here we go again. Follow along. It says a 4th root, so type in the number 4 first. But I want this radical to be there. So what do? We press the second button, the green one, and then press the power button. So press the power button. So there it is. Look at that. 4th root. 4th root. And what am I going to put inside? The 16. So type in your 16, hit enter, and there it is. My answer is 2, just like we did right here, just like we got in that problem. So now let's see what happens to this one. So for letter D, remember, this is the one that said not possible. So let's see how the calculator handles something like this. And remember, I'm not typing this in. I'm typing this in right here. So I'm going to do a 4th root. So again, I'm going to press the number 4. I am going to press the green second button, so the green button, and then the power button. There it is, 4th root. It's got to look like this, just like we wrote it. And now I'm going to put in a -16, not minus, -16. So -16. All right, hit enter, and look, the calculator, this is the calculator's way of saying, hey, you can't do this. You're not allowed to work a problem out like this. Well, that's why we wrote not possible, right? We tried it out, nothing worked. So when we see this on a calculator, that's the calculator's way of saying, hey, this is impossible, you can't do it. So then we just leave it like that. We just say not possible. We don't write error or anything else. Okay? So right now you're going to use your calculator to make it a lot easier, and you're going to work on these practice problems. So we're going to, in a little bit, we're going to pause the video. Now you see this one is ready. This one is ready for the calculator. Number 2, it has a negative in front. Well, guess what? It's ready for the calculator. Just write your negative first, right? Because we know it's going to have it. This one is not ready. Remember, this is the new thing. When you see a power that's a fraction, it means turn it back into a radical. And if your index is a 2, we want to know what the index is. Well, if your denominator is a 2, well, then that's where we put our 2. and then the 25 goes inside. Again, you need to fix these. Just like we fixed negative powers the other day, we have to fix these too. So when I look at number 4, no, I'm not ready for a calculator. As soon as I see a power that's a fraction, I turn it back into a radical. The negative 25, yeah, you throw that in there, negative 25, and now it's all about the index. If the denominator is a 2, then the index is a 2. And now you're ready to type all these into the calculator. All right, so take a quick moment, try these out, throw them into the calculator, and then we'll check your answer shortly. So we're going to pause the video right now. All right, so let's see if you got these right. Remember, this is the 4th root of 81. So I actually have this ready to go, 81. 4th root of 81. Let's see if you got the right answer. You should have gotten the answer of 3. Now, this is exactly the same thing. So if you did this on the calculator, yeah, there's your negative outside, so we wrote it, but then you should also still have a 3. All right, now square root of 25. Now you could do it this way too. You could type in the 2. You could do a second root, see, square root of 25. Your answer should be a nice little 5 as well. So there's the answer. And then, of course, there's this one where I'm going to, once again, I could type in the 2, second square root. So there's my square root right there of negative 25. And look at that. As soon as we get that message of error, you were supposed to say that this is not possible. Can't be done. All right, so keep that calculator handy. We're going to keep using it. So flip the page over. We're going to do the last concept of the day. Last idea, which has to do with this, what we just practiced. So it's a little bit more. All right, so rational exponents. When we hear the word rational, well, to us, rational just means fraction. When we hear them say exponents, well, exponent just means power. So what they're saying is, when you see a fraction as a power, fix it. Remember, the way we fix it is rewrite it as a radical. So just rewrite it as a radical. That's what we do. So as soon as you see a power that has a fraction, fix it. All you have to do is rewrite it. And so here is your reminder once again. Again, this is the big idea of the day. It says, if a to the power of 1 over n is given to you, then all you have to do is turn it into a radical. Remember, your base is a, so there's the a. And all we have to do now, remember, my denominator is n. Well, then that means my index is n as well. All we have to do is put it where it belongs. So, again, rule number 1, right? This is the index. Write that in, see if we can make it fit. All right, so rule number 1 says, if you have a to the power of 1 over n, then turn it into n root of a. Again, your index is your denominator. Now, quick little example, of course. So, for example, if it says 5 to the power of 1 over 3, well then, I see a fraction, I turn it into a radical. The 5 is the base, so that goes inside. You don't mess with that. But what am I going to write as my index? Well, don't forget, if my denominator is 3, then my index is also 3. So right now we're just talking about rewriting, nothing else. But that's just a quick little example of what that means. Again, if you see a power that's a fraction, rewrite it. You got to fix it. Now, there is a different variation of it. So here is rule number 2. And rule number 2 says this. Okay, so it's a slight variation of this. It says, what if you have a to the power of m over n? So yeah, there's your fraction. And if you see a fraction, we said, turn it back into a radical. My a is my base that goes inside. And of course, the big thing is that whatever your denominator is, well, that's your index. So we write our n. Now, if you're wondering, well, what about that m? Well, you actually have two options. Whenever we have the m here, all you do is just write it on the outside. There's where my m goes. It's still a power. The n is the only one that becomes your index. Now, you do technically have another option. This one we won't see as much, but here's my radical. Here's my a. And look, this is still your n. This is your index. But here's your other spot that you can put the letter m, right here. Okay? All right. Now, so I want to give you an example of this one. So a quick little example here. So if we say 27 to the power of 2 over 3. Okay? 27 to the power of 2 over 3. All right, well, again, we see a fraction, so I write a radical. Now that I wrote it, here's my 27, so there's my 27. But keep in mind, this is my denominator. Then that's my index right here. This is what I write in there, the 3. And then the 2 that's on top, remember, you could just throw that out on the outside. And that's what we're going to do the most. But that's the meaning of that fraction. When you see a power that's a fraction, again, you see a power that's a fraction, turn it into a radical. Okay, so here are the last few examples for the day. Notice, for this example, example number 2 and example number 3, it says rewrite it. They don't want you to use a calculator. They just want you to change the look. Number 3 also says rewrite it. They don't want you to use a calculator. They just want you to change the look. So let's get the practice going. Again, I see a power that's a fraction, which means I'm going to turn it back into a radical. The 64 is the base. Well, then put the 64 inside. This is the only thing to remember. That index, that denominator becomes the index. That's what we write in here. And then, of course, you do have that power of 3. Then surround it with a power of 3, and we're done with that problem. All they said was rewrite it. They don't want you to do any math with it. And a lot of your work for today, that's all you have to do. All right, here we go again. Look, again, it's meant to be nice and simple. We're just practicing how to rewrite. It says 27. It has a power that's a fraction, which means I write a radical instantly because of this fraction right here. The 27 is the base, so I write the 27. All right, let's look at my denominator. My denominator is 3. So my index is 3. And what about that 4? Well, remember, that 4 that's on top, you just leave it on the outside. Just leave it out there. Just like we left the 3 outside, the 4 on top just goes outside as well. We are rewriting. We don't need a calculator yet. So that brings us to number 3. Again, they said rewrite. They don't want you to do any math. You are just rewriting. But when you look at these, you say, wait a minute, they already have the radical. Well, if they want you to rewrite it, the only thing you can do is turn it back into this. So we're going backwards now. So my base is 6, so there's my 6. But remember, when you see a radical, that means it's a fraction. Now, what is my denominator going to be? Well, remember, don't forget where we look. We always look right here. We see the index of 3. Well, the index is your denominator. That's where your 3 should go. And of course, there is a power on the outside. Or remember, that's what goes on top. And then that's it. There's my answer. I don't do anything else to it. Okay? We are just rewriting. No calculator needed. And then there's this one. So for this one right here, it says the cube root of 5 is equal to 7. Now, remember, there's nothing here. It's invisible. Don't forget, it's not a 1. In the world of radicals, there is an invisible 2 here. So now I'm ready to rewrite it. So according to the rewrite, I'm going to write a 5. That's the base. I see a radical, so I write a fraction. And of course, my index is 2, so my denominator is 2. And then, of course, the 2 right here, my index, right, is down at the bottom. But that power of 7 goes on top. And that's my answer. Again, we are just rewriting. All right, so with that said, everybody, that's pretty much today's concept. Just so you know, maybe we could do a couple of these just so you see them. For your practice problems, all they said was evaluate. Okay, so maybe we should talk about it. See, evaluate means use the calculator. Okay? Use the calculator. Now, we see a power that's a fraction. Okay, I'm going to rewrite it. So this is where we practice what we learned. I see a fraction, so I write a radical. The 64 is the base, so I throw the 64 in there. My denominator is 3, so my index is 3. The number on top is 2, so then I surround the whole thing by 2. Now I'm ready for my calculator. So when I do this on my calculator, though, let me show you so you can practice. Here, let's clear that up. All right, let me put it side by side there. Okay, with the calculator, the first thing you should do is handle the inside. Let's leave that 2 alone for now. We can do that later. My concern is, can you do this part on the inside? So, cube root. So don't forget, you press the 3. All right, there's the 3 on the calculator. You press the green button for second and press the power button. There it is. See, now it looks like that. And then do 64. All right, let's see what that is. All right, so we got a 4 for it. So there's a 4. Now I can use my power button. Now this is just a regular power button. So it's 4, and look, you can just do it right underneath, to the power of 2. So I press my power button. Don't forget, this right here is our power button. You don't need to press second this time. Power of 2. Press enter, and there's my answer, 16. So when they say evaluate, that's when you use a calculator. If it says rewrite, it means rewrite it and then stop. So, well, look at this one. This one is also almost ready for the calculator. We're going to do a little fix, though. See, I'm going to keep the 5 as my index. I'm going to keep the radical. I'm going to keep the 22. But remember what we talked about earlier. When you have a power in here, you could also write it on the outside. That's why I needed to show you that note earlier. So when you see it in here, man, feel free to write it on the outside. And now this thing is ready. So I'm going to use my calculator. But first, I'm only going to work with the inside part. So there's my 3 waiting. But now I'm going to work with the inside part first. So here's what I wanted to show you. All right, so take a moment here. Check it out. 5th root. So 5. Second power button. There it is, 5th root of 22. Now I want you to notice something here, okay? Look at that. 1.8, and we didn't do anything wrong. Don't think you did something wrong. It's perfect. But we don't want to round off. We want to use the exact. So I'm going to write 8, 5, 5, dot, 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 dot. But don't erase it. Leave it alone. We need to use the entire thing, and I want to give the entire thing a power of 3. Well then, don't mess with the calculator. Leave it alone. All you're going to do is press the power button. Press it right away. And look, the calculator is going to take that answer, and now it's ready to give it whatever power you want, which is a 3. Again, it's taking your answer and giving it a power of 3. So when I hit enter, there it is. Now I can round it off. And all I'm going to do is call it 6 point, well, it's not a 3. Because there's an 8, we're going to round it up to a 4. So when you get to these, just try your best with them. I know it's not perfect, but there's the idea. So today it's a lot of calculator practice, okay? All right, so with that said, you're going to jump right into today's homework right after this. So use the rest of the time wisely and have a wonderful day, everybody.